On this video, I will discuss t-test for two independent samples. The t-test is a test of difference between two independent groups. Two groups are said to be independent if the occurrence of one group doesn't affect the occurrence of the other group. When do we use the t-test for independent sample? We use it when we compare the means of two independent groups. We also use it when the data are normally distributed and when the sample is less than 30. Why do we use t-test for independent sample? It is because t-test is more powerful test compared with other tests of difference of two independent groups. How do we use the t-test for independent samples? We use the formula T is equal to x sub 1 bar minus x sub 2 bar divided by the square root of the quantity of SS sub 1 plus SS sub 2 divided by n sub 1 plus n sub 2 minus 2 times the quantity of 1 all over n sub 1 plus 1 all over n sub 2. Where T is the t-test, x sub 1 bar is the mean of group 1, x sub 2 bar is the mean of group 2, SS sub 1 is the sum of squares of group 1, and SS sub 2 is the sum of squares of group 2. N sub 1 is the number of observations in group 1, and n sub 2 is the number of observations in group 2. So for us to apply t-test for two independent examples, let us have an example. Two groups of experimental rats were injected with tranquilizer at 1.0 mg and 1.5 mg dose respectively. The time given in seconds that took them to fall asleep is hereby given. Use t-test for independent samples at 0.01 to test the null hypothesis that the difference in dosage has no effect on the length of time it took them to fall asleep. So we have here the following data. So under 1.0 milligram dose, we have the following data, and under 1.5 milligram dose, we also have this following data. Then, let us solve using the stepwise method. First is to state our problem. So on our example, the problem is there a significant difference brought about by the dosages on the length of time it took for the rats to fall asleep? Then, for the next step, we have the hypothesis. So we will formulate our hypothesis, specifically our null hypothesis and the alternative hypothesis. So for the null hypothesis, it will be there is no significant difference brought about by the dosages on the length of time it took for the rats to fall asleep. And the alternative hypothesis, which is the reverse of the null hypothesis, we have there is a significant difference brought about by the dosages on the length of time it took for the rats to fall asleep. So those are our two hypotheses. Then the next step will be the levels of significance. So first, we have our alpha. So alpha at 0.01. So it was stated a while back on our example to test using the alpha 0.01. Then we also have df, which stands for the degree of or degrees of freedom. So for t-test for two independent samples, df will be equal to n sub 1 plus n sub 2 minus 2. So on our example, our n sub 1 is 11 and our n sub 2 is 9. So that will be 11 plus 9 minus 2. That will give us 18. So our degree of freedom is 18. And the next one is to find for the t tabular value or the critical value. On this, we will be using the t table. So we have here the t table. As you can see, we have here the rows for one-tailed test and for two-tailed test. And on this section, we have the degrees of freedom. So our test or our example is an example of a two-tailed test. It is because the hypothesis or the example is a non-directional hypothesis. It means that it doesn't go right, it also doesn't go left or up or down. So that is a two-tailed. So under two-tailed, let us find for our alpha, which is 0.01. So it is located here. And on our degrees of freedom, let us find for 18. So this is 18. Then let us get their intersection. So the intersection of 0.01 and 18 is 2.878. So that is our t tabular value. So why is it that it is positive or negative 2.88? It is because our example is a two-tailed test. Meaning to say that there is a value on the right side which is a positive and there is also a value on the left side which is the negative. That is the levels of significance. And next will be the statistics. So under here, we are now going to solve for the given problem. So we'll be using t-test for independent samples. And we are now ready to solve for the t-test for two independent samples. So let us go back with the data a while back. So we have 1.0 milligram dose, which is our x sub 1. Then we have 1.5 milligram dose, which is our x sub 2. So we have the following data under x sub 1. Then getting now the summation that is equal to 118.7. Then for our n is the total number of data, which is 11. Then for our x sub 1 bar or the mean of x sub 1, that will be 118.7 divided by 11 will give us 10.79. And on this section is x sub 1 squared. Meaning to say, we will square the data on x sub 1. So that will be 9.8 squared will be 96.04. 13.2 squared is 174.24 and so forth. Then we have the summation of x sub 1 squared, which is the sum of this data. That is 1309.25. So we also applied the same process on our x sub 2. Since we already have the following values, then we are now ready to solve for the sum of squares. So the sum of squares is given by the formula the summation of x squared minus the quantity of the summation of x squared divided by n. So let us first get SS sub 1, or the sum of squares of the first group. So we have the summation of x sub 1 squared. So the summation of x sub 1 squared is equal to 1,309.25. So that will be 1,309.25 minus, so the quantity of x sub 1, or the quantity of the summation of x sub 1, that is 118.7. So that will be 118.7 then squared divided by n sub 1, or the total number of the data, which is 11. So evaluating it further, so when we evaluate this further, this will give us 28.37. And next will be the SS sub 2, or the sum squares of the second group. So for the summation of x sub 2 squared, that will be equal to 1,140.84 minus the summation of x sub 2, which is equal to 100. So that will be 100 squared divided by n sub 2, which is equal to 9. So evaluating it further, that will be equal to 29.73. So we now have the sum of the squares of the two groups. Now let us solve for the t-test. So this is our formula. This is the formula for our t-test. So let us now substitute all the given values. So that will be equal to, so for our x sub 1 bar, or the mean of the first group, is equal to 10.79. So that will be 10.79 minus the mean of the second group, which is 11.11. Then on the denominator, we have, so for our SS sub 1, which is 28.37, then plus SS sub 2, which is 29.73, divided by n sub 1 plus n sub 2. Our n sub 1 is 11, plus n sub 2, which is 9, minus 2, times, so 1 all over n sub 1, which is 11, plus 1 all over n sub 2, which is 9. Then close parenthesis. Then let us evaluate it further. So that will give us, so 10.79 minus 11.11 is equal to negative 0.32. Then on the denominator, we have 28.37 plus 29.73 is equal to, so that will be 58.10. Then divided by 11 plus 9 minus 2 is equal to 18. Times, so 1 all over 11 plus 1 all over 9 is equal to, that will be 0.2. And evaluating it further, so that will be negative 0.32. Then we have 58.10 all over 18 times 0.2 is equal to the square root of 0.646. Then that will now be equal to negative 0.40. After solving for the t-test, then we are now ready for our decision rule. So for our rule, if the t computed value is greater than or beyond the critical value, this confirms HO. So on this case, on our example, the computed value is negative 0.40. And our t tabular value is equal to positive negative 2.88. In order for us to visualize if our computed value goes beyond or within the critical value, then let us illustrate it using our curve. So that is a two-tailed test. Then the mean will be here. And on the right side, we have the positive critical value, which is 2.88. Then on the left side, we have the negative critical value, which is negative 2.88. Then let us locate our computed value, which is negative 0.40. So it will fall maybe here. As we can see that the computed value is within the tabular value of positive negative 2.88. Therefore, the t computed value is not greater than or is not beyond the t tabular values. It is within the t tabular value. Therefore, we will confirm our null hypothesis. Then let us now make our conclusion. Since the t computed value of negative 0.40 is within the critical value of negative 2.88 and positive 2.88 at 0.01 level of significance with 18 degrees of freedom, the null hypothesis is accepted. This means that no significant difference was brought about by the dosages on the length of time it took for the rats to fall asleep. So that is the t-test for independent samples.